What's up, everyone? My name's Phil, and I recently acquired a GoPro. And so I thought I'd put it to good use and start my new YouTube channel. And with no real good ideas in mind about what to do videos on, I decided to start out with a day in my life video as a cognitive science PhD student at Vanderbilt. And the reason I use cognitive science, my PhD will really be in psychology. And the reason I use cognitive science, though, is because the program that I'm in is actually called Cognition and Cognitive Neuroscience. So cognitive science just does that a little more justice than psychology, which is very broad. But specifically what I do is I study spatial memory and spatial navigation. And so I have participants come into the lab and perform various navigational tasks in immersive virtual reality. So all of my experiments are programmed in virtual reality using a video game development software known as Unity. And so essentially I program up these tasks for participants to come in and complete using virtual reality. It's really cool stuff. And so what I'm doing now is I'm walking to campus. It's about 1:30 in the afternoon. The reason I'm just now walking to campus is because my morning was really just full of virtual meetings and virtual seminars and all that nonsense. So because of all the COVID stuff that's going on. And so, nobody can tell that you just rolled out of bed and are on the computer from home if you just keep your webcam off. So I slept in a little later today and took care of all that stuff, and now it's time to go to campus and get some real work done. So there's plenty of things that I need to do today, but first I'm going to get some lunch because I haven't eaten anything since yesterday and my body's fucking starving. So I'm going to stop by a place called Helen's Hot Chicken. So if you've ever been to Nashville, you know that Nashville is known for its hot chicken, but I'm not actually going for the hot chicken, although their hot chicken is very good. It's their catfish sandwich that I'm really in love with. So I'm going to stop by there and get some lunch, and then we're going to hit the lab and get some work done. Alright, so I'm here at Helen's Hot Chicken, sitting by the fire pits and stay warm, despite the fact that even though it's February, it's fucking hot as hell outside. It feels like it's April. So anyways, while I wait for my catfish to get here, I thought I'd tell you a little bit about where I am in the program. So I am a third-year student, which would typically mean that I would be working on my qualifying exam right now. However, so the typical process, the milestones you have to hit every year. So your first 2 years, you have to present your project to a committee. Got my stuff. Thanks. This is the waiter giving me some stuff, but in your first 2 years, you present the research that you've been working on to your committee, and then in your third year is when you have to complete your qualifying exam, which allows you to move on to doctoral candidacy, at which time you would start working on your dissertation proposal. And so the qualifying exam is usually done at the end of the spring semester in your third year. However, I did mine a little bit early. I finished mine back in January, so I'm technically already a doctoral candidate student. And so what the qualifying exam is you have to write what's called a MAP, which stands for Major Area Paper. And it's pretty much just a review article that you write. It's like 40 to 60 pages, somewhere around that range, and mine was like 55 pages. And then you have to pass an oral examination that is held by your committee. The reason I finished mine so early is because I was already writing a review article for publication, and I figured that I could just use that as my major area paper and just get that out of the way early. So I'm technically a doctoral candidate at this point, but I'm still in my third year. So what I'm working on now is my dissertation proposal. Alright, so I just finished eating lunch. I am now on campus right next to the library, and I'm walking to the lab. There's a few different things I need to do today. The primary thing, though, is not actually to work on my dissertation proposal, but I need to begin programming an online experiment that I'm planning to launch soon. So I mentioned before that most of my experiments involve running participants through immersive virtual reality experiments. However, when the pandemic hit, most of the in-person studies were canceled for a short period. They're back open now. But as a consequence, I had to transition some of my studies over to online. And there are various third-party web services that allow you to, or that will host online psychology experiments. But because my experiments require participants to navigate through virtual environments, I needed to have a web service that would allow me to publish my 3D environments for people to navigate through using mouse and keyboard. And there just simply weren't any third-party web services, at least none that I know of, that were compatible with the types of experiments I was doing. So over the summer, I created my own web server, and I figured out how I could publish my Unity games or my experiments on my web server. And so now I can host some of my experiments that don't require people to physically move around, as in the immersive virtual reality stuff, on my web server, and anybody can connect to it from all over the world. So it's really easy and really quick data collection. And my last online experiment just recently concluded, so I need to get another one up on my web server, but I still have to program it. So that's what I'm going to work on today, and maybe hopefully I can finish that this week, because it's going to be using a lot of the same code that I've been using for previous experiments. So I should be able to program it pretty quickly, and then I can get back to working on the dissertation proposal. All right, so we have made it to the VR lab. This is the tracking space inside of this camera here and the camera over in the corner that we use for our VR experiments. And this is our super sweet gaming computer that we bought for the lab that supports all of our VR stuff. Really jealous I don't have it in my room, but I'll buy one of these days. But for the next 2 to 3 hours, it's time to sit down and get some work done. So I decided to take a little break from programming to share with you a little bit more about one of the main areas of research that I'm working on, which is the integration of sensory cues during spatial navigation. So when we're moving about in the world, we have access to various cues out in the environment, like landmarks and visual entities like that. But we also have cues that come from within the body, so vestibular signals and proprioception and motor efference copy and things like that. And so the idea is that people can combine these different sensory cues to enhance their representation of where things are in the world and where they've been and how to get back to those locations, which makes intuitive sense, right? So I mean, if you have 2 pieces of information as compared to 1, you can make more informed decisions by definition. And so this area of research is concerned with the manner in which people integrate cues and whether or not they do so optimally. So we can develop models of optimal sensory cue integration And then we can perform experiments to see if not only do they integrate the cues at all, but whether or not they do so optimally. And so that was the topic of my qualifying exam. So I'll show you a few of the slides that I used just to illustrate the problem. So anybody who is, see if I can get it better, might just have to hold the camera, familiar with the show Futurama knows that this is Fry here. And so let's just say that Fry was at the park and he's just finished up a picnic. Maybe he got, the coveted date with Leela or something, and they went to the park for a picnic. And now he's just gotten back to his car and he's freaking out because he realizes he doesn't have his keys anymore and that he left them somewhere over at the picnic site. And so now the task that Fry is stuck with is that he needs to relocate where the picnic site was so that he can find his keys. And so one of the things he can do is he can recall that the picnic site was somewhere in front of the tree line up on the hill. But another thing he can do is try to recompute the distance and the direction that he traveled from the picnic site. And so the dilemma that he's in here is, well, which cues should he follow, right? Because neither of the cues are perfect indications of where this target location is. So wouldn't it be nice if he could combine the cues in a way that would increase the precision of his mental representation of where this location was? And so the model that we use is this Bayesian model here, where we can represent the probability of a given location being the target given cues x and y. So we can just say that qx is the landmark cue, or the tree line, and qy are the cues that come from the body. And so we can say that the probability of the location given those two cues is equal to the probability of those cues given the location multiplied by some prior, so some prior probability over the locations divided by this marginal probability here. And so we can ignore the marginal because all that does is just ensure that the integral over this posterior here is equal to 1. So we can ignore that for now. And then we can assume that the two cues are independent, so we can separate them out like this. And we can show that this posterior here is just proportional to the probability of the location given each cue, right, multiplied by each other. So if we have these two single cue distributions here, so this blue distribution is the distribution of location, so the probability of a location given the visual cues, with the red distribution being the probability of the location given the self-motion cues, we can represent their optimal combination as this distribution here, which is the product of the blue and the red distributions. And the reason we call it optimal is because it maximizes the likelihood of the location given those two cues. And so what we do then is we develop an experiment in which we have single cue conditions. So we have a condition in which the participant performs some navigational task with just the visual cues, and then another condition in which they perform the task with just the self-motion cues. And so what that gives us is a response distribution for each of those single cues, and the means and variances of those response distributions approximate the means and variances of these underlying probability distributions. And so we can use those parameters of their response distributions to predict what optimal performance should look like when they have access to both of the cues. And then what we do is fairly straightforward. We just have a condition in which they perform the task with both of the cues, and we look to see if the parameters of their response distribution are equal to the parameters of this optimal distribution that's predicted based on their performance from each of the two single cue distributions. Let's see. So what we do is we can compute the reliability of a given cue as 1 over the inverse, or excuse me, 1 over the variance, or the inverse of the variance given that cue. So we have them perform in, let's say, the visual only condition where they only have access to the visual cue, and then we take the inverse of their variance of their responses in that condition. That's the reliability of that cue. And so then we can compute the weight that should be given to that cue, which is equal to its relative reliability. So the reliability of that cue over the sum of the reliabilities of both of the cues. And so the mean of this optimal distribution here is then equal to the linear combination of those weighted single cue means. And the same holds true for its variance as well. And so what we do then is we compare the variance, the mean and variances of their response distribution in the dual cue condition when they have access to both the visual and the self-motion cues to the parameters of the optimal distribution. If people really are optimally combining the cues, then the parameters between those two distributions should be similar. So that's just the general framework that we're working within. But we're doing all sorts of experiments right now where we're looking to see whether or not the rules of cue combination or cue integration are different depending on the types of cues that are being integrated. So people are fairly optimal when integrating visual and self-motion cues, but there seems to be different rules at play when people are integrating cues of the same sensory type. And it also depends on how noisy and how variable certain cues are. So in some cases, people will just ignore cues entirely if they figure out that the cues are totally unreliable. So if you have the landmarks switching positions between trials, people tend to just ignore them and go with the self-motion cues. There are all sorts of different conditions or boundary conditions that describe or explain how people combine the cues. But that's just a little bit about what I do. All right, so I just finished up working on the online project that I was describing earlier and doing some grading for a class that I'm TAing for. So what I'm working on now, this is the Unity editor that I was describing earlier, and some code I'm working on for a project, a collaborative project that I am working on that's being headed by this otolaryngologist at Johns Hopkins University. And she studies patients who have vestibular issues. And such patients have problems with balance and steering through environments. They often run into obstacles in their local environment. So the steering is just a fancy term that's used to describe how you move around or steer around objects as you're moving through a hallway, for example. And so people with vestibular impairments have difficulty doing this. I mean, it's a really easy task for somebody like myself who doesn't have vestibular impairments, but for such individuals, they're often bumping into things. And so what this otolaryngologist wants to do is develop a diagnostic tool in immersive virtual reality that can be used to diagnose such individuals with having such impairments. And so what I'm doing is I'm creating this virtual environment, this virtual task where people navigate through a series of hallways. And while they're doing so, they have these trackers that are attached to their arms and to their feet. And we can record whenever a tracker collides with any of the virtual obstacles that they run into as they're traversing the hallways. And so the basic idea is to have both typically developing people as well as people who are known to have these vestibular impairments navigate through this environment. And then we can norm the data and see where the differences are between typically developing people and people with vestibular problems. And in that way we could design, or might be able to design, a diagnostic tool that could be useful for diagnosing people with this type of disorder. All right, so it's almost 6 o'clock. So I'm going to go ahead and make my way home. But I think I'm going to stop at the Village Tavern, which is this really small bar on 21st Avenue. It's probably like a 10-minute walk from campus. And they host like dart tournaments and all that stuff. But I just go to get the gumbo and have a few drinks after work. But I usually only go if I walk, and I don't ever stop there if I drive to campus. But since I walked to campus today and I have to walk home, and it's on the way. I think I'm gonna stop in and have a couple drinks. So I'm gonna go there, do that, and probably get some more grading done on my phone, and then I'll go home from there. All right, so finally leaving Village Tavern and am on my way home. Man, there was a fucking weirdo at Village Tavern tonight, just sitting at the edge of the bar talking to himself all night. Really strange, creeping me out for sure. But anyway, finally on my way home. I don't really have anything left planned for the night, other than to just go home and maybe watch a few episodes of Malcolm in the Middle and maybe get some more grading done. That's really about it. I guess that concludes the day in the life. This will be my first YouTube video ever, so I don't really plan for this channel to be primarily centered around my life as a student. I really just plan on posting videos or discussions, maybe rants about various topics. So if you have any questions or suggestions on what I might talk about next, feel free to leave a comment in the comment section. Otherwise, I'll see you guys next time.